Maybe at some point it will work. Not really sure. So it seems to work now. Very good. So this is the overview. You press the escape button, right? Keyboard top left, escape back and forth, small big. And in the overview, you use the cursor, the little arrows, and then you can go left and right, up and down. And if you have selected a different slide, let's say this one, oh, that becomes big. Right? So you go from an overview to a particular slide. Okay, when we go to the first slide back again, you see, what, I even have a laser pointer today, over here, little arrows. That means you can go down and to the right in the slideshow. Right? Down means you follow a subsection, like a topic, like a chapter in a book. If you push the button to the right, you jump one chapter. Let's see. I push down. Oh, use Python as a calculator. 2 plus 2, 2 minus 2, 2 times 3. You have seen that last time, right? Worked beautifully. So now you have, like, what is it? A 2,000 euros, 1,000 US dollar, 30,000 NTD calculator. Okay. Well, please note, now I have an arrow to the up, so I can go upwards again. So I go to my main slide. When I push to the right, I'm in the next subchapter, 1.1. So far, so good. And then we can go down and see what's there. Very good. So these are my slideshows. And I have my slideshows from my, here's it. Is it here? Did I copy already? I have it from my iJupyter notebook. So I'm in my work folder here, right? I create a new Python kernel. So sorry, iJupyter notebook. And I could, in principle, any of these notebooks download as HTML. No. Reveal JavaScript slides.html. Okay. So I get there for my notebook. There are a few other steps I will show you over the course of this program, this course. So at the end, you will know as much as I do, if not even more. Okay, so how to do now? So we have slides, but programming is an acquired skill. So we don't want to look at slides all the time. What I recommend you is you will have a notebook open next to the presentation where you can try to like copy paste the code either from the notebook, right, or you type it yourself. So let me arrange that how I would like to use it. Let's see. So the live stream has died, right? Something is off. And nothing I can do about this now. It's about the data rate, apparently. Well, then it is how it is. I tried. Okay. I would do it like this. So I have my slides on the left, right? The slides still work as slides, right? Everything is a little bit smaller. But at the same time, I can go to the right and now try whatever is written on the left. Right? If you look carefully, there is written 5, modulo 1. And modulo is like the percent symbol. And then I press Shift Enter, and I get the same. So I have an input, sorry. I have an input, I have an output as given in the slides, but we never trust anything. We are scientists. We check, we confirm. So I take the code, I put it on the right, and I execute to check that everything is as it claimed. So far, so good, right? So it works, so there are at least no errors. Lastly, I need to use my head to interpret the result if this is correct or not. Well, and what we haven't talked about is that this one here is the remainder operation. So what is 5 divided by 1? Everybody looks at the slide now. No? 5 divided by 1. 5 divided by 1 is what in Chinese? Divide by 1. Chinese translation. Maybe not everybody understands. Here, speak in the microphone. Okay, give back. U Chui, correct? My Chinese is good? Okay. U Chui. So the result is what? U Chui. How much? 5, right? Okay. What is 5 divided by 2? Is it 2? 5 divided by 2 is 2.5, right? 5? Some people shake their head. Okay, we have a disagreement. Let's check Python. 5 divided by 2 is what? 2.5, okay? Okay, but now we go back to primary school. When we go primary school first, we do not know floats. We don't know rational numbers, right? So what does the teacher tell us? 5 divided by 2 is 2, 4, and there's 1 unit left over. We can't divide. That is the remainder. So when I now type 5 modulo remainder 2, that is 1. Okay? Remainder is what in Chinese? You forgot, right? Remainder is what in Chinese? Okay, good, thank you. Okay, so let's see. So the slides. For convenience, check here, everything is fine. For convenience, I go back to the bigger screen. And I will switch between my windows, right? So you can see better on the whiteboard, right? But you yourself can do whatever you like most. Okay, so let me check Python as calculator. So go down, plus, minus, divide. Very good. This is the remainder we just spoke about. But now I'm very curious. So this is the wrong window. Does Python actually know all the different laws of physics? There's the associative law, there's the commutative, so the exchange of parts. So when I have 5 times 5 plus 2 is how much? $27, right? Maybe I zoom a little bit, make it a little bit larger. 5 times 5 is 25, plus 2 is 27. Okay, and now 5 times 5 plus 2 is how much? It's not 27 anymore, right? How much is it? If English is a problem, that I can handle in Chinese as well. So what is it? 35. Okay, let's see. 对，很好. So Python knows brackets. Okay, So Python knows the brackets. Very good. Okay, so back to the slides. Oh, why do I always 1, 2, this one? Okay, so when we are at the end of one section, the arrow down is vanishing. Right? When you look here in the overview, there's no slide down, so we need to go to the right. Okay, push right button. Variable assignment. So a variable is an object with a name, right? A variable has a name, and I will store a value in it. In general, when we have a variable, we must assign a value. We cannot just have like a variable. So my variable name is variable, and I execute. Oh no. Python will tell you name variable is not defined. So if it's not defined, how do I define it? Well, I need to give it some content. So far, so good. Do you remember the equal symbol? Is it big enough to see at the back? I see some. Maybe I do a little bit larger. Not sure anymore. So here now for everybody large to see, yes, variable 0. So now I have stored the value 0 through the equal sign. Right? So this is not an equal, this is a programming operation that takes the value on the right and puts it to whatever is on the left. So I give the value 0 to the variable. I also can have my height. What do you think is my height? 2 meters, correct, very good. Obviously not, right? My weight, obviously 200 kg, no, let's say 100 kg, different values, right? So I have assigned now 2 variables with values. Okay. So far, so good. Nothing too new. You have seen something similar before, but what else can we talk about today? So briefly again, symbols or variables can store information. Right? My weight, my height. Information can be numbers, including integers. These are whole numbers. 0, -1, 1, -2, 2. Floats or rational numbers are 1.2, 0.9, right? Everything with a finite amount of digits. We run a little bit into trouble with irrational numbers because of the numerical accuracy we have available, right? We have a discrete data, we can't, well, there might be some tricks around that. Okay, we also can have Boolean values. So Boolean is a special type of number. It is only 1 or 0, true or false. Now there's one trick to it. If you have a Boolean number that is 10, that is also taken as true, right? As long as you have a value that is true. But the standard is true or not true, false. We saw that last time as well when we compared number, right? Is 4 smaller than 5? True. That result was a Boolean variable. Okay, sometimes, however, we want to store not only numerical data, we want to store basically text, letters. So let's see. it's not a value per se, and there's nothing stored in this variable. To make it a text, I'm going to put this in quotations. Quotations are the little thingies here. So they make it a string. So far, so good. So now when I check my name, yes. If you look very carefully, you see that I use double quotations. Right? So here are two of the thingies, and here's only one. Wait a moment, maybe I did a mistake here. I need to change this to one only. Well, it also works. So actually you can use double quotation or single quotation. Good. So what else? So we have string, booleans, integers, and floats. And these are the most common data types we are going to use. So when I ask you what's an integer, a float, a boolean, true, false, or string, you should be able to answer that. Or when I tell you which data types are in Python, integer, float, bool, string. There's one more. A character. You know characters, right? Chinese language knows a lot of characters. Let's see what I can do here. Oh, I also know characters. Very good, right? So, but do I know how to use them? Very good. So I even can store Chinese characters. Be careful here. And it should work. Yes. Okay. So far, so good. So characters. Now, my name has how many characters? I can ask Python how many characters has my name. And it will tell you 6. Let's count again. 1, 2, 3, 4, 5, 6. Yes, very good. So a string, in principle, is just a collection of characters. I'm not really sure why this is funny here, right? It's no idea. We manage. So I have no idea what this gray block here. Anyhow, so when I want to, for example, access the first character, my name, in my name, I will use the so-called index notation, right? Square brackets. The type of bracket we use is very important. We distinguish actually between square brackets, curly brackets, and round brackets, okay? So square brackets, curly brackets, round brackets, all very different. But when I want to have access to a character in my name, I use the square brackets, and the first character sits at index position 0. So we start counting at 0, not at 1. Okay, and there's the J, right? I can go for the second character at index 1. There's the O. Are you trying this now with your name? I'll play around a little bit. I can even say, like, I don't know. I will do this later. Okay. So far, so good. There are, however, a few things we must consider that are allowed when we provide names for variables, and not the content, but the name, and what is not allowed. Okay, let's go through this slowly. So we must not start with a number. No number in front, okay? For the name of a variable, and not the number, not an operation, not a bracket, and no quotations. So in short, right, use letters and underscores. But there are small details we can make use of. We don't have to. We can follow these naming rules, and your variable names should be fine. Okay, let's practice. So my first variable. Okay, so what do we put inside? My first variable, what content shall we choose? How about 3 times 3? So this works, right? I try to copy this a little bit hard with one hand. Copy here. So my first, I now change the naming and put like first variable, right? You see that? The one st, right, is short for first. That's how you can do it in a text when you write it. But in Python, because we start with a number, Python will complain. And it will tell you invalid decimal literal. Decimal means number, literal means like naming, right? And invalid means like it's wrong. We don't allow. I'll go back here. Must start with a letter, not with a number. So your variable name here starts with a number, right? Cannot. Let's try again. Let's bracket this. Yeah, also cannot. Let's do an operation in front. Plus. Also cannot. What else do we have? We have the bracket, we have the operation, or quotation. This is fun. So I put my variable name in quotations. Cannot. Okay? So when you see an error while you assign a value to a variable, it could be a mistake in the naming conventions. Or better said, could be a mistake not following the naming conventions. Questions? Still easy, right? Right? Some examples. Okay, so not very exciting Monday morning. To keep you awake, I have put in my slide little tasks. Tasks, many S here. This is task 1. Check if the following are permitted variable names. You have the slides, right? So now I want that you tell me which of the variable names is allowed and which one is not. How about I give you 5 minutes, and then you tell me true or false and why. Okay, time's up. So this task, how do you solve it? Who wants to give it a shot? It's too easy or too difficult? Too easy, right? No? Okay. If it's too easy, then we can make it short, right? So we copy. I would copy it. Then I paste it. And then I'm going to split. How do I do this? I think over here, cells split. And then I just try to assign a value. Oh, this works. Capital A works fine. Small a works fine. Right? A underscore B works fine. A minus B. Will it work? No, because we have an operation on the left to which we want to assign a value. That doesn't work, right? It's not one variable name, it's two. Okay, no, that doesn't work. Multiplication, the same, it will not work. Operation in front will not work. Number in front will not work. Number behind the letter, will it work? R1, will it work? Yes, no, maybe? Will work, right? Because we could have an R1 and R2. We have an R2D2. Right, robot. Songstand Darshue, very good. School. So we can assign values to mixed, to variables with mixed letters and numbers, but not starting with a letter. And our variable names even can be written with Chinese letters. However, if you use Chinese characters, if you use Chinese characters in your variable naming, I have a hard time reading your code. And having nice names for your variables makes your life easier to read the code. Okay? Okay, so what else do we have? No? Okay, here again, what are integers? Integers are numbers, well, positive natural and negative naturals, including 0. Floats are real numbers or even actually complex numbers, and strings, well, sequences of characters. Now, do we have an example of a complex number? Let's write down one complex number. How do we do this? So complex number has an imaginary part, so we must find the imaginary unit in Python. So here I have used 7 plus 6j. Do you remember the naming conventions? So when I write 6k, that doesn't work. A, B, C, D, E, F, G, H. Oh, let's try H. A, B, C, D, E, F, G, any other letter. Try it out. It will not work. But if you write 6J, doesn't this violate our naming conventions? Well, let's see if you can assign it a value. So this doesn't work because 6J is not a variable, it's a number. And here it's 6 units of the complex, it's 6 units of the complex unit, I. But we're not using I, we're using J. So what's the difference? If you look very carefully, if we zoom in as much as we can, if I have 6I, 6 is in green font, I is black. Green font here means, oh, Python knows what it is. It comes with Python, it's one of Python built-in stuff. If I have 6J, suddenly my J is green, right? This indicates that actually J is the value of the complex unit. Okay, how can we check what J is? When I just write J, suddenly Python tells me J is not defined, right? Isn't that weird? Like over here, we know what's J, down here we don't. So there's a difference between a variable and a number, right? For the variable, we said it cannot start with a number. But a number starts normally with, how do you call this, a number. So when I want to have J as complex unit, I put just a number in front like 1J, right? 1J is I, so I get 1J. If I multiply 1J with 1J, what do I get? -1, right? There we go. So that is one of the reasons why we have these naming conventions. So my variable names must not start with a number, so I still have control over my complex numbers. Right? So this is well defined when and how to use what. There is no ambiguity. Ambiguity means like you can interpret it in more than one way. So far so good? I see a little bit of confused faces. Shall I spend more time on this? Was easy. Okay, we move on. Good. So this is an example, or was an example of a complex number with imaginary unit. So task 2, assign an integer or boolean or float number and a string to 4 different variables. Assign an integer, a boolean, a float number, and a string to 4 different variables. Right, and here is given again as a reminder what is a string. A string is a collection of characters. So here we actually don't need to wait too long. It's pretty easy. We need to make an integer. We need to make a Boolean. We need to make a float number and a string. Sorry. To 4 different variables. A, B, C equal, assign, sorry, D. Does it work? Very nice. Okay? So far, so good? So again, right, so the task here is assign an integer, Boolean, float, and string to 4 different variables. So I selected integer, a Boolean, a float number, and a string. Oh, sorry, typo here. String. And I choose 4 different variables, A, B, C, and D. So far, so good? Okay. Nothing new so far. We have done this last lecture as well. However, Python gives you a lot of flexibility in its syntax rules. So we even can write A, B, C, D equal 1, true, 1.1, a string. Will it work? Yes, it will work. Okay, so we can assign multiple values to variables at once. So we can do it one by one. A equals 1, B equals 2, blah, blah, blah. Or we can make A, B, C, and so on equals all the values. Now make sure that the number of variables on the left, A, B, C, D, I have 4 variables, equals the number of my values. Now I have only 1, 2, 3. So what do? I create an error message. And the error message is very helpful because it tells you, oh, not enough values to unpack. Unpack is fancy for like, I have 4 variables expected, but I only got 3 values. We also can give too many values, sorry. So when we have too many values, right, not enough variables, then too many values to unpack, expected 4, then you count. 1, 2, 3, 4, yes, we have 4 variables, and 1, 2, 3, 4, 5 values. That doesn't work. So far, so good? Makes sense, right? If I have 10 students on my course, but they give me 11 exams to correct, something doesn't add up, right? No. Okay, same with variables and values. Good. Okay, let's see what else do we got. It's now 10 o'clock. Do you want a break? Okay, 休息10分钟。